Welcome back to our last lesson of Unit 8. A lot of the problems that you're going to see today are going to look very familiar, but they're just going to be slightly more challenging than the problems we've seen so far this unit. So I'm excited to see how well we respond to the challenge. Today we are combining everything we have learned thus far in the unit to solve complex problems that involve area of compound figures. Before we jump in, a quick reminder of expectations. Please make sure you have something to write with and a place to take notes, as well as your classwork today, which is in Google Classroom. Lastly, just take a second to make sure you are in a distraction-free zone and your phone is away. And with that, we are going to jump in today by looking at our very first problem. Before we do, though, I want us to just reground ourselves in all of the shapes that we have learned how to find the formula of, both in this unit and earlier this year and last year in 5th grade. This chart should look familiar because you saw it a few lessons ago, but what you see here are all of the shapes that we know we have formulas to find the area of and the corresponding formulas. Our first question we're going to look at together says, what is the area of the figure below? As we talked about yesterday, the first thing I realized when looking at this figure is that it is a compound figure, meaning that in order to find the area, I must decompose it into shapes that I know how to find the area of. Shapes like rectangles, triangles, trapezoids, parallelograms, or even squares. Now, the easiest way for me in order to split these up, there are multiple ways, but the way that seems easiest for me right now is to split it up like you see here where I just drew that red line. That will then give me a rectangle and a triangle. That's helpful because I can easily find the area of a rectangle and a triangle. You guys should know how to do this. So we're going to start right away by releasing you. Pause the video and take 90 seconds to find the area of the rectangle and the triangle. Compare your work with mine. As you can see, the area I got for the rectangle is 160 square feet. The area that I got for the triangle is 70 square feet. As a reminder, I found the base for the triangle as 20 by using the property I know about rectangles, which is that opposite sides are congruent. Because I saw a 20 on the top of the rectangle, I knew that the bottom of that rectangle was also 20 feet long. The last step here is to add together my two areas, and when I do that, I get 230 square feet. Pause the video to make sure you have your work matching mine. And that quickly brings us to our key point for today, which was just as we did in the coordinate grid and with our shapes yesterday, the area of compound figures can be found by decomposing them into familiar shapes. We're going to see some interesting looking compound figures today, and we know that we can decompose them into 2 and sometimes even 3 shapes that we know how to find the area of. Pause the video to write down your key point for today. Now let's solve a more complex word problem together. It says, Miss Petaway wants to carpet the floor of her first floor. She drew a diagram of the first floor below. The carpet she wants to buy costs $5 per square meter. How much will it cost to carpet the entire floor? Now, this is a word problem, so we know that before we dive into solving, we need to reread this word problem and ask ourselves, what is this question asking us to find? And then what plan can I write in order to find it? Pause the video and take 60 seconds to answer those 2 questions in your Google classwork. Go. When I unpacked this problem, the first thing I annotated was carpeting means I'm covering, and that means I need to find the area. Then I annotated my goal, which was to find the cost to carpet the entire floor. Then you can see the 3 steps of my plan. The first is to decompose into familiar shapes. That's from our key point. The second is to find the area of each shape and then add them together to find the total area. Lastly, I need to multiply my total area by 5 to get the total cost. If each square meter costs $5, I need to take the total number of square meters and multiply it by 5. That will give me my total cost. So let's look at this together. As I look at this shape, there are a few ways in which I could decompose it. The first one I know off the bat is to draw this line here, which would give me a rectangle at the top. I see another rectangle at the bottom, but that middle shape looks a little interesting. What is the name of that middle shape? Your teacher's going to pause the video and see if anyone knows. You're exactly right. If you said trapezoid, the middle shape is a trapezoid. So now I have decomposed this figure into 3 shapes, 2 rectangles and 1 trapezoid. Why is that going to be helpful? Because I know how to find the area of all 3 of those shapes. You guys are experts at finding the area of rectangles, and I'm curious to see if you remember our lesson from a few days ago in terms of finding the area of the trapezoid. Take the next 2 minutes to find the area of each of these figures. Work organization is going to be really important, so make sure you're keeping track of all of your dimensions and all of your formulas when solving. Pause the video to find your 3 areas now. As you can see, I identified the length and width of rectangles A and B, which should be pretty straightforward. I want to quickly review the dimensions of the trapezoid. Base 1 and base 2 were 24 and 4. Those actually weren't labeled on the actual trapezoid, but I used the properties of rectangles that opposite sides are congruent to realize that my 2 bases were 24 and 4. If you had those switched as base 1 being 4 and base 2 being 24, that's fine as well. Next, I know that the height is 2 because that is the vertical distance between my 2 bases. Then when I substituted all of these values into the correct formulas, you can see I got 288 square meters for rectangle A, 28 square meters for rectangle B, for trapezoid B, and 24 square meters for rectangle C. Pause the video to check your work with mine and make sure you have the 3 correct areas. But that's not all. I'm going to post the plan that we showed earlier. We have done about 1.5 steps in our plan. So with our plan there, now it's your turn to finish this problem. Take the next 60 seconds to find the final answer to your problem and write an answer statement. Go. When you added your total areas, you should have gotten 340 square meters. And then when you multiplied that by 5, you should have gotten $1,700. Our answer statement then for this question is, it will cost $1,700 for Miss Petaway to carpet the entire floor. We just used our key point and the skills that we've learned all throughout the unit in order to find the area of complex figures. This problem we just solved was our most complex one yet because we had to decompose our shape into 3 separate figures. Remember, as you are working today, annotate your problems. Make sure you decompose your figure into shapes that you know how to find the area of and label your dimensions. You might need to find missing dimensions using properties of rectangles. You know how to do that. Write your formulas, show all of your calculations, and then last but not least, answer statement is provided. Thank you all for your attention today, and for an awesome Unit 8, I'm excited to jump into our next unit together. Bye.